Smart optical sensors for Internet of Things, integration of temperature monitoring and customized security physical and plannable functions. Internet of Things has been a widely explored concept in nowadays society, acting in the most varied areas such as industry, smart cities, and healthcare. For the evolution of IoT, smart labels are fundamental. Among them, luminescent quick response codes arises the ideal interface between the user and the IoT, and since they can be printed on virtually any substrate with different materials, distinct features can be attributed to them, such as temperature sensing and security functions. Therefore, they can be the answer to healthcare services limitations, which were amplified by COVID-19, acting as tools for temperature tracking, identification, and remote medical care. With that in mind, we propose univocal temperature sensing smart labels based on QR codes. The IoT interface is guaranteed by the QR code. For their authentication, they are explored as physical and plannable functions, and for the ability to sense temperature, they are studied as luminescent thermometers. Resulting in functions such as authentication and monitoring with reliability, we are able to develop e-health smart labels. For that, we need a luminescent ink and distinct substrates. The carefully chosen luminescent ink is based on an organic-inorganic hybrid doped with a complex with a lanthanide ion europium, whose emission intensity varies with temperature changes. The chosen substrates for the labels were protection medical masks and medical adhesives. Under daylight illumination, our labels show the basis QR code, enabling open access to generic information. However, under ultraviolet illumination, the luminescent ink becomes visible, forming a random pattern that is the response of our physical and plannable function, enabling posterior unique identification and authentication. Moreover, the luminescent ink in combination with the non-luminescent one allows the label to function as a temperature sensing probe, enabling real-time sensing and self-monitoring. Using a user-friendly smartphone app, both features of the smart labels can be accessed and used for distinct applications. But how is this possible and how can it work in our day-to-day lives? First, we have to produce our labels. Initially, a regular black and white QR code is stamped on the substrate. Once it is ready, we can pass to the artistic part using our luminescent inks. An S state is used as a mask to restrict the painting area. Then, we are all set to airbrush the ink on the label, using for that an aerograph. Finally, we can see the result of our label by putting it under ultraviolet illumination. These type of labels have potential to be used in several scenarios. Here is an example of how they can be used for the univocal identification and temperature tracking for access control of specific areas. Here, we developed univocal sensing smart labels that can be used for temperature self-assessment, identification and temperature tracking for access control, and also for remote medical care. Therefore, we showed to you how luminescent QR codes have the potential to be the new generation of optical IoT technologies.